Hello everyone. In the last class we have discussed angle between two lines and the shortest distance between two lines, two skew lines. Okay, dear students. So dear students, we have discussed the distance between two skew lines in a vector form. In the last class we have discussed in the vector form. So what is the distance between two skew lines when it's passing through the given lines? Is D is equal to B2 minus A1 dot B1 cross B2 divided by magnitude of B1 cross B2. This is the formula which we have discussed and which is one of the very important questions also we have discussed in the last class, correct? Because this is the theorem which they will ask for the final mass. So now vector form you got, there is a distance between two skew lines in the vector form is this one we got. Now we need to discuss the what is the distance between two skew lines in the Cartesian form. Okay, so the Cartesian form, see dear students, now B1 cross B2 we know that is one vector and A2 minus A1 is also one vector. That means it is nothing but just the vector dot cross product of these two vectors, means we will be getting a scalar triple product. Just I am trying to take you back. Okay, so this is now scalar triple product of three vectors. This is one vector and here two vectors. So scalar triple product of three vectors. So now scalar triple product of three vectors we know. So that is A2 minus A1 is nothing but x2 minus x1, y2 minus y1, z2 minus z1. Correct? And next B1 cross B2. The vector B1, position vector of B1 is here. I mean the direction ratios of B1 is A1, B1, C1 and direction ratios of B2 is A2, B2, C2. Correct? So now this I got. The upper part is this one I got. Now divided by magnitude of B1 cross B2 means the magnitude of cross product of B1 and B2. So we know that the cross product of B1 B2 cross product is nothing but we need to find out the ijk determinant. It's determinant, correct? So if you find the magnitude of B1 and the cross product of B1 and B2, you will be getting one output. And next I want the magnitude of that one. So here B1 cross B2 means you will be getting one vector. B1 cross B2 means you will be getting one vector. Now I want the magnitude of that vector. So magnitude of that vector will be, see dear students, B1 C2 minus B2 C1 whole square plus C1 A2 minus C2 A1 whole square plus A1 B2 minus A2 B1 whole square. Don't be confused. Here we need to find the B1 cross B2. Here that all process is not required, but you must know how we got this one. First you need to find the B1 cross B2. It's cross product. So when you do the cross product, as you all know, you will be getting one new vector. Okay. Next I need to find out the magnitude of that new vector. So the magnitude of the new vector means x square plus y square plus z square. Okay. Still if you get confused, see. Simple way you can write this because B1 C2 minus B2 C1 whole square plus this is because A1 C2 minus A2 C1 whole square plus if you close this one A1 B2 minus A2 B1 whole square. Clear there students? A1 C2, here it is A1 C2, A1 C2 minus A2 C1 minus A2 C1. Yes, this is the way we'll be getting this one. Okay, so next two. This up here, please keep in mind, this will be we are having for 2 mass and this will be 3 mass. Okay. Now, next very important thing is, yes, we discussed now the distance between the two skew lines. Means the lines which are neither parallel nor intersecting each other, correct? Okay. Then what is the distance between two lines when the two lines are parallel to each other? When the two lines are parallel to each other. Okay. Just imagine now here, two lines are, let me take the two lines L1 and L2. Let me take two lines L1 and L2 which are parallel to each other. Okay, which are parallel to a new vector B also, over vector B also. Okay. So now here let L1 be the with equation A1 plus mu vector B means this is parallel to vector B. Okay, and passing to the point A1. Now let me take the equation of L2 is vector A2 plus lambda into vector B means it is passing through the point A2. It is passing through the point A2. Okay. Now let me take the here S and T. Let me take the point S and T on line L1 and L2 with position vector A1 and A2 respectively. Please keep in mind, I am taking here 2 points S and T on line L1 and L2 with position vector A1 and A2 with position vector A1 and A2. Okay, and let P be the foot of perpendicular of a line P be the foot of perpendicular of a line which is drawn from the point T. Okay, which is drawn from the point T. That means it is perpendicular here. Okay, so now I need to find the distance between these both the vectors. I mean these both parallel lines. I need to find the distance between these both the parallel lines. So what is the distance between these both parallel lines? So the distance between these both parallel lines are nothing but here it is now PT. Correct? The distance between these both parallel lines are now PT. So I need to find the PT. Now let me take it as a D. Let me take it as a D. So now I need to find the D. Okay. Now let theta be the, please keep in your mind, this L1 and L2 both are parallel to each other and these both lines are parallel to vector B. That means now whatever vector you are taking here, that will be nothing but all. Just here I have taken an angle theta between vector ST and L1. Okay, that L1 is nothing but vector B. So I am taking here, please keep in mind, let theta be the angle between vector ST and vector B. Vector ST and vector B. That's the, okay. So theta is the angle between vector ST as well as vector B. Okay. So now apply the cross product form ST and vector B. Now the cross product of vector B and ST is equal to, we know already, the cross product of vector B and ST is equal to magnitude of B into magnitude of ST into sin theta n cap, whereas n cap is the unit vector perpendicular to the plane L1, the plane which has the L1 and L2, means coplanar planes. So please keep in mind, L1 and L2 are coplanar because both lies on the same plane, parallel to each other. Okay, then n cap is the unit vector which is perpendicular to both the vectors. So both the lines L1 and L2. Okay, that is perpendicular to L1 and L2, means that is perpendicular to that plane. Okay, so now we know that ST is nothing but, see, vector ST is equal to here, terminal point is T, initial point is S. That means A2 minus A1, because the terminal point, position vector of terminal point is A2 and the position vector of initial point is A1. Okay, so it is nothing but A2 minus A1. Now vector B is equal to, please, vector B cross ST is nothing but vector A2 minus A1 is equal to magnitude of B, please keep this one, in this triangle SPT, in this triangle SPT, if you apply the sign for this, means sin theta is equal to opposite divided by hypotenuse, means PT divided by ST, PT divided by ST. That means PT is equal to, you will be getting ST comes this side, correct? So PT is equal to ST into sin theta. So please keep in your mind. So here I have taken, in place of magnitude of ST into sin theta is nothing but PT. Magnitude of ST into sin theta is nothing but PT into sin theta. Now let me take the magnitude of these both. Okay. So now when you do the magnitude of these both, I will be getting here magnitude of B as usual, and PT is the distance between these both lines, L1 and L2. That's nothing but, you can write magnitude also. So it is nothing but 1. Magnitude of n cap is 1 because it's a unit vector which is perpendicular to both. Okay. So next to here, I need here PT, which I need to find out. That means distance between these both the lines. So let me take it as a D, or let me write it as it is D. PT, keep it here itself, and if you take this to this side, so you will be getting finally magnitude of B cross A2 minus A1 divided by magnitude of B. Please keep in mind. D, I mean PT is equal to magnitude of vector B cross A2 minus A1 cross divided by magnitude of B. This is, please keep in mind, see, this is the distance between two lines when these two lines are parallel to each other. Once again, when two lines are non-parallel, means Q lines, this is the distance. This is the distance between that two lines. Okay, and suppose if they are asking the Cartesian form, means this is the distance between that two lines, that is Q lines. If the given two lines are parallel, this will be your formula. See, for this, just note this point, this formula, and this one, please. This one is very, very important for the 5 marks which they may, or which is repeated many times in the examination point of view. Dear students, let's move to the now exercise 11.2. Okay. So in this exercise, the first question is like this: show that the three lines, means they have given the three lines with the direction cosines. So please keep in mind, they may give you direction cosines of the line, or they may give you direction ratios of the line. Okay, here they may ask you prove that it's a perpendicular to each other, or they may ask you prove that it's a parallel to each other. So whatever it is, you must know the condition for perpendicularity or condition for the parallel lines when the given two lines, whether with respect to direction cosines or they may given the direction ratios. Okay, so now let us continue that one. So now let's see here direction cosines of the three lines, whereas the direction cosines of the first line is 12 by 13, minus 3 by 13 and minus 4 by 13. Direction cosines of the second line is 4 by 13, 12 by 13, 3 by 13, and the direction cosines of the third line is 3 by 13, minus 4 by 13 and 12 by 13. So now let us check out what they are asking. Show that means prove that it's a perpendicular to each other. So we know that whenever the given lines are perpendicular to each other and whenever they are given direction cosines, so what is the things we need to clear? So we know that, please keep in mind, we know that when two lines are perpendicular to each other and the direction cosines of that two lines are given, then it has to satisfy, this is the condition. So the condition is L1 L2 plus M1 M2 plus N1 N2 is equal to 0. Okay, now let us check it out. Please, I am doing here for the first two lines, this and this line. I am doing for this and to this line. Okay, so they are asking, show that all mutually perpendicular, all three lines are mutually perpendicular to each other, you have to show. That means you need to prove this into this for this both, and for these both, and for these both. Okay, now I am taking these both, I am taking. Okay, so now for this both, let me L1 is equal to 12 by 13, L2 is equal to this one, sorry, L1 is equal to this one, M1 is equal to this one, and N1 is equal to this one, L2, M2 and N2. Now apply the formula. L1 into L2 means 12 by 13 into 4 by 13 plus M1 into M2 means minus 3 by 13 into 12 by 13 plus N1 into N2 means minus 4 by 13 into 3 by 13. So when I do this one, I'll be getting, see here, 13 into 13, 13 into 13 is nothing but 169, whereas the LCM of these three terms is 169. Okay, now just simplify this one. 12 4 is 48, and this will be minus 36, and this will be minus 12. So finally we will be getting numerator part as a 0. So finally the output is 0. That means when I do this, or when I apply this property for the given two direction cosines of lines, then I will get them 0. That means these two lines are perpendicular to each other. These two lines are perpendicular to each other. Similarly, you need to prove. Please do yourself. These both are. Means take this as L1 M1 N1 and this as L2 M2 N2. Prove that if you do this operation or if you apply this operation, you will be getting 0. Similarly, for these both, apply and make it prove. I mean perpendicular to each other. Okay. So now let's move to the next question. So the next question is like this, students. See, the first question, show that given three lines are perpendicular to each other. Okay. Whereas the direction cosines were given. So in this, let us check out what they were given. Okay. Show that the lines through the points, means the lines is passing through the points 1, minus 1, 2 and 3, 4, minus 2. Means there is a one line that is passing through 2 points, these 2 points. Okay. That line is perpendicular to the another line which is passing through 0, 3, 2 and 3, 5, 6. Means two lines given, that two lines are, instead of their given direction cosines, here they are given the points of 2 points of each line. Okay, so now let the given points be, let me take it as A, B, C and D. Okay, so first I need here, they are given the points of that particular line. I need to find the direction ratios of the given line. First I need to find the direction ratios of the given line. So first let me find out the direction ratios of AB. So when I do the direction ratios of AB, say dear students, 3 minus 1 plus 4 minus of, minus 1 is 4 plus 1 plus minus 2 of minus 2 is nothing but we'll be getting this one 2y plus 5z minus 4k. Okay, this is the my, please keep in mind, AB, it's my AB with direction ratios 2, 5 and minus 4, 2, 5 and minus 4. Okay, similarly, the direction ratios of CD, let me find out the direction ratios of CD. So direction ratios of CD I will be getting here 3i plus 2j plus 4k, means 3, 2, 4. Direction ratios of the CD is 3, 2 and 4. So now, previous problem we were having the direction cosines. Now in this we are having the direction ratios. So when we have the direction ratio, how to prove? How can you conclude that the given two lines are perpendicular to each other? So it has to satisfy this property. So what's the property? What's the condition? So when they have the direction ratios, to say that these two lines are perpendicular to each other, it has to satisfy this property. So the property is A1 A2 plus B1 B2 plus C1 C2 is equal to 0. Let us check it out. Okay, that A1 B1 C1 and A2 B2 C2. So we will be getting 2 into 3 plus 5 into 2 plus 4 into minus 4 means minus 16. We will be getting 6 plus 10 minus 16, which is nothing but equal to 0. So since it's satisfying this property, therefore you can say that finally AB, line AB is perpendicular to CD. AB is perpendicular to CD.